How to Lie with Statistics by Darrell Huff. Welcome to this video. Too many people are inherently innumerate and poor at understanding probability and statistics. This leaves them wide open for deception and manipulation. Don't be that person. Darrell Huff's How to Lie with Statistics has stood the test of time, selling over 500,000 copies. It doesn't teach you how to lie with statistics, but rather how we can be lied to with statistics. Even in 2019, we are routinely misled by crafty media spin doctors, marketers, politicians, and newspapers daily with statisticulation, just as much as it was in 1954 when this book was written. We make purchasing decisions and form opinions on any number of topics based on data analysis done by others. If you're one of those people who buy a particular brand of toothpaste because 4 out of 5 dentists recommended it in the commercial, then we might have a bit of work to do. Statistical thinking will one day be as necessary for efficient citizenship as the ability to read and write. H.G. Wells. Think of statistics as a way to make sense of information from data. Think of it as a framework for thinking, for reaching insights and solving problems. Numbers by itself means very little unless we provide some context behind it. This makes statistics part math, part science, and part art. We need to be able to describe data and infer meaning from it. These are the two fundamental challenges of statistics because we can make mistakes in our interpretation. People tend to become much more reluctant to offer credence when they encounter a statistic that is incongruent with their own beliefs. In contrast, those same people are remarkably less scrutinizing when it suits them. Let us examine Huff's messages in an attempt to understand why this book has achieved such notoriety and fame. In a time where big data, big science, and analytics are ascending in the business world, it behooves us to review statistical concepts. For those of you who enjoy statisticulating and numbers, I plan to have future book reviews on that topic, which will go more into depth. For everyone else, at least some degree of statistical literacy is important. And How to Lie with Statistics by Darrell Huff is a book without complex mathematics and equations for those of you who fear math. This book will serve as a basic conceptual guide that anyone can follow. The sample with the built-in bias. Statistics is about analyzing data, but not just any data will do. When we want to make inferences from data, we need to ensure that representative samples were taken from a population. It is rarely possible or cost-effective to collect all of the data from an entire population, so rather we gather a subset of data from a population and then use statistical methods for that sample to draw conclusions about that population. If we tried to gather information from the entire population, that would be quite difficult and expensive. Statistical inference is the process of making an estimate, prediction, or decision about a population based on a sample. Shrewd marketers can deliberately twist numbers in order to sway potential customers, but a biased sample introduces error without having to twist numbers. Having a representative sample is as important as the foundation of a house. Without it, your study is on shaky ground and will fall apart. Biased samples are much more common than you think. A large sample that is selected appropriately from a population should represent the whole well enough. If it isn't, we end up with an intelligent guess and have nothing to recommend but a spurious air of scientific precision, as Duff says. But even if you're confident about the dependability of a sample, keep a small degree of skepticism about the results. Duff provides an example of sampling bias from a 1936 presidential election with candidates Alfred Landon, who was the Republican governor of Kansas, versus the incumbent President Franklin D. Roosevelt. The Literary Digest sent a mock ballot to 10 million people from a list collected in 1932, 4 years prior. They received 2.4 million replies from the survey, which is actually quite a good response rate. Based on the results, the Literary Digest predicted that Landon would win by 370 electoral votes to Roosevelt's 161. But their predictions did not quite pan out. Roosevelt won by 523 electoral votes for only 8 for Landon. Roosevelt also received 62% of the popular vote in the election. So it turns out that the Literary Digest sample was not a representative sample of the United States' voting population. The Literary Digest used various lists for their sample, including the Literary Digest subscribers and owners of cars and telephones. Their sampling was neither random nor was it representative of the United States' voting population. Their sampling bias was towards people with more money, more education, more information and alertness, better appearance, more conventional behavior, and more subtle habits than the average of the population. Increasing the size of the sample is not a panacea for erroneous sampling methods, which actually would just compound the mistake. Rule number 1. Determine if the sample for the data you are dealing with is both random and representative of the whole population. Measures of central tendency. Let us talk about the 3 measures of central tendency, namely the mean, median, and mode. Understanding this concept will have you questioning more deeply when somebody tells you that, for example, half of the world lives on less than $2.50 a day, or that the average person reads 12 books in a year, or the average CEO reads 4 to 5 books a month. I hope your skepticism radar starts to blink when you hear these types of numbers, because it's very likely that those numbers are skewed. The mean is a simple average or an arithmetic average, which is denoted by mu for population and x bar for a sample, and their formulas are presented here. The problem with the arithmetic mean is that it can become problematic because of outliers. So let's do an example. Suppose we want to compare the price of haircuts for women between Vancouver and Toronto. And we have a list of values here. The average for Vancouver would be $72, while the average for Toronto would be $36. Based on this, we might conclude that it costs twice as more for a women's haircut in Vancouver versus Toronto. The problem is that we included one posh salon in Vancouver where they charge $400, which greatly increases the average value. If we remove this outlier, the average for Vancouver would be $25, which is actually less than Toronto. And I'd also like to assure you that I do not spend $400 per haircut. And actually I cut my own hair. So now that we know that the mean is not enough, we can calculate the median, which is essentially the middle number in a data set. To calculate the median, you order the numbers in ascending order and record the number at the middle point, which we would get $24.5 for Vancouver and $29 for Toronto. But we still don't get the full picture, so we introduce the mode. The mode is the most frequently occurring number, which is $20 for Vancouver and $25 for Toronto. Which measure is best, you might ask? There might not be a best one, but it's probably better to know each of the 3 measures for a better understanding of what is happening with your data set. When the mean equals the median and it also equals the mode, we have something called a normal distribution or a bell curve. This distribution is also called a Gaussian distribution, and it's the most common distribution in statistics. The term Gaussian celebrates the famous German mathematician Carl Friedrich Gauss. Every normal distribution has certain properties that distinctly characterize it. 1. The shape is symmetric, such that the left side is a mirror image of the right side. The majority of the probability is towards the middle of the distribution and decreases as we move into the left and right tails of the distribution. And 3. The mean, median, and mode are all the same, and we can find them directly in the center of the distribution. However, not all distributions are in a perfectly symmetrical bell curve. Some distributions are skewed left or right. The direction of a skew, either left or right, tells the direction of the tail that causes the lack of symmetry. So for example, distributions of populations are generally skewed to the right. A large proportion of people have modest incomes, while a very small percentage might have higher incomes than the rest. So this causes the average household income, which is the mean, to be higher than the income earned by the majority, which is the mode. On the other hand, a negatively skewed distribution has a long tail on the left side, which suggests that there are outliers that are much smaller in value than the majority of the observations in the distribution. For a negatively skewed distribution, the mode is greater than the median, which is greater than the mean. The mean is pulled lower by the outliers in the tail in the left side of the distribution. Rule number 2. When given a statistics, ask if it represents the mean, median, or mode. Sample size. We spoke previously about the built-in bias in a sample and that the sample should be representative of the population and randomly selected. We need to ensure that the sample is also large enough to draw conclusions about the population. How often have you seen YouTubers tell us how to do a diet or how to use a product based on their N of 1? They use their small samples and draw a sensational headline. You intuitively know that one person's opinion is not enough. Duff reminds us to be suspicious of a small sample. The accuracy refers to how close your measurement comes to the true value without any systematic bias. Remember, systematic bias is built-in error which makes all measurements wrong by a certain amount. The precision refers to how close a replicate measurements are to each other. You need data that are reproducible. Based on this diagram, we can see the difference between accuracy and precision. So suppose you hear that a new toothpaste users report 40% fewer cavities. You should review how the experiment was conducted, how the sample selection was conducted, and if there were sufficient numbers of toothpaste users versus a control group. The value you are looking at could be accurate and precise. This is what we would want the value to represent. Inaccurate but precise, accurate and imprecise, or inaccurate and imprecise, which is what we definitely do not want. Rule number 3, inquire about the size of the sample versus the entire population. You might have heard that statistics can either be descriptive or inferential. Descriptive statistic refers to how large volumes of data are converted into useful, readily understood information by summarizing their important characteristics. Inferential statistics, or statistical inference, refers to methods used to make forecasts, estimates, and to draw conclusions about a larger set of data based on a smaller representative set. Duff provides an example in the book about intelligence or IQ tests. Peter and Linda are siblings. Linda's IQ score was 101 and Peter's was 98. The normal IQ score is 100, and therefore the parents concluded that Linda is their smarter child and is above average, while Peter is their less fortunate boy. So how accurate is this IQ score? Is Linda really smarter than Peter because she scored 101? To understand this, we need to consider confidence intervals. The standard error for the Stanford-Binet IQ test has been found to be 3%. This has nothing to do with how good the IQ test is basically, but only with how consistently it measures IQ. As such, Peter's IQ might be more fully expressed as 98 plus or minus 3, and Linda's as 101 plus or minus 3. This means that it's equally likely for Peter's IQ to fall anywhere between 95 and 101. And similarly, Linda's IQ is equally likely to fall in the range of 98 to 104. The point estimates are 98 and 101, and the ranges are the confidence intervals. The ranges are much more accurate representation of reality. So from this you can see that there's an equal chance that Peter's IQ could really be above normal, and a similar chance that Linda's is below 98. You have probably heard of the terms like standard error, standard deviation, the variance, confidence intervals, and you might have even seen their formulas. I do think that one should take a look at some of these and actually do the calculations to grasp the concepts. However, the author for this book didn't really get into that in the book, so I will also leave it at a high level. Rule number 4. When provided with a value, ask for the range or confidence intervals. Correlation does not imply causation. We might say that describing relationships and cause and effect among variables is how we understand the world. We can use statistics to describe and measure how two variables are related. We could compare income levels and happiness, coffee consumption and weight gain, or postgraduate education with career advancement. But let's assume that higher income levels correspond with more happiness in life. However, even if it does correspond with more happiness in life, we still can't conclude that higher incomes cause increased happiness. Correlation gives a quantitative measure of the strength of the linear relationship between two varying quantities. The correlation coefficient is a number between -1 and +1, where +1 denotes a positive straight line relationship between the variables. Suppose we wanted to see how more square footage in a house correlates with house prices. In general, these two variables move together, meaning the more square footage a house has, the higher the house price. This relationship moves in one direction. A correlation coefficient of 0 represents the absence of any straight line relationship. For example, coffee consumption in India is not correlated with house prices in London, England. These two variables do not have anything in common. A -1 denotes a perfect inverse straight line relationship between the variables. So for example, let's think about the sales of gelato and the sales of umbrellas. More gelato tends to be sold when the weather is warm and sunny. On the other hand, more umbrellas are sold when the weather is rainy. This is a negative correlation. When one goes up, the other goes down. Meaning, when the gelato company makes more sales, the umbrella company does not make as many sales. But I also hope that you can see that higher gelato sales do not cause fewer umbrella sales. Rule number 5. Do not infer cause and effect from correlation. Just because X and Y are correlated does not mean that X causes Y. They could both be caused by some other factor, Z, or actually Y might cause X instead. How to gesticulate. Let's introduce the concept of absolute risk versus relative risk. Suppose 1 in 10,000 will develop a skin disorder called grayscale, which is my throwback to Game of Thrones, and that some environmental factor, such as traveling through old Valyria, increases the risk to 2 in 10,000. When we introduce that environmental factor, the relative risk is 100%, or it's doubled. However, the absolute risk only increases to 2 out of 10,000, or 0.02%. Therefore, doubling of risk, or the relative risk in this case, can be used to exaggerate the effects of both the developing of grayscale and the environmental risk factors. You can easily be misled if it's not made clear which type of risk you are dealing with. Duff also talks about post hoc ergo propter hoc. This Latin phrase is a logical fallacy in which it is assumed that B is caused by A simply because B follows A. Let's give an example of a sharpshooter. Think about a bow and arrow aiming at the side of a barn and then drawing a target around where the arrow is landed, claiming that he shot a perfect bullseye. Post hoc analysis refers to choosing criteria or interpreting the significance of those criteria after you know the outcome. Post hoc analysis is so very highly prevalent, so watch out for it. Final thoughts. One component of critical thinking is basing your beliefs on actual evidence so as to arrive at conclusions that are reliable with some understanding of how reliable your conclusions are. How to Lie with Statistics encourages statistical thinking in a non-mathematical way. If you take information with a grain of salt, and hopefully it's because you have developed a critical, skeptical mind, which in my opinion is a very good thing. Acting on all different types of information thrown at you or forming an opinion requires an understanding of statistics and some math. For that reason, I think this book is more almost like a pre-statistics book to help people conceptually understand some statistical topics. Following this book, I hope people are further interested to deepen their understanding of basic statistics from other sources. If you do read this book, expect to see examples that are emblematic of the 1950s and before that, and nothing from 2019. But the general concepts still apply. But some of the things I also didn't cover that the author reminds us about is to check the labels on graphs and photos for signs of manipulation of the truth. Fast forward to 2019, everywhere you look you'll see infographics, so be discerning and check the labels. A framework the author offers his readers consists of 5 questions to ask. Use these questions to stare down a statistic. 1. Who says so? 2. How does he know? 3. What's missing? 4. Did somebody change the subject? And 5. Does it make sense? If you like this video, please click the like button, share this video, and subscribe to my channel. Click on the bell icon if you'd like to be notified of new video uploads. I have an amazing lineup of reviews and books coming every week. Remember, leaders are readers, and you are a leader.